have Mr. Kitical. He's on the top plate of the extra coil resonance. Don't worry about that. He's insulated from one of them electrified plates, and even if he wasn't, it wouldn't matter, I would guess. We'll see that Mr. Kitical, he's going to move probably pretty soon. As soon as he gets off that plate, the circuit will go resonant. Kitty, 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 kitty. Well, when the circuit goes resonant, what you do is you'll see that neon bulb light up. Now, for some good reason or not, Mr. Kitical was to take, for instance, his tails to touch that bottom plate, and his other paws to touch the other plate in front. Well, he might have a shocking experience. We got to coax Mr. Kitical out of the picture now and look at the actual resonance. Come on, Kitical. Come on. As we can see then, Mr. Kitical left the plate and it's resonating. So on down the line of things that's going on with this. We got 1 volt stators because we haven't energized the field. We got 1 volt goes up to 8.5 volts on phase 1. On phase 2 goes up to 2.4 volts from 1.2 volts. It only doubles. And on phase 3 it goes up to 11.2 volts from that 1 volt. And instead of having all the interphasal amperage meters together, we've got each one showing what voltage is doing what. The 2-3 sequence goes first. It is 11.8 volts enabling 4.2 milliamps. We now have 2 coils on top of this bugger. Then we got the second coil, which is another 2.4 Henry coil. It's got 9.2 volts enabling 8 milliamps. And then we got the third element, which is 20.6 volts enabling 2.38 milliamps. Then we've got the fourth element by itself as an auto transformer. It's consuming about 1.3 milliamps. Now we'll look at the changing conditions then. What we could do is we could, well, what we'll do is we'll go right from here. What we're going to do is show, we can see that 68.5 Henry milliamp consumption. And we can see the tube there with the neon. And that's the central electrode of the third final resonance. And that central electrode determines the capacity with the outer electrode by surface areas and water, intervening water, and PVC tube as the dielectric. Now when I'm going to go in there and touch that live circuit and raise that tube up out of the water. Now when we raise that tube up out of the water, what we should expect then is that the 68.5 Henry resonance, the third resonance, should not resonate because we're changing the capacity. And when we're doing this, we're going to be able to look at the 20.5 volts input and the 2.4 milliamp as I try now to bring it out of resonance by lifting the central electrode. On one side of this neon. We're almost completely out of the water, and yet the amperage of that resonance is staying the same. synthesis of what the next step needs to be for the Nazi doll replication. We're not going to go any further now. We're going to turn the device off. And we're going to go back over here to our chart and try to explain in time itself the progression of events. This is the first 2.4 Henry resonance that we could add to the internal voltage rises of the Delta series resonance system. That would be the first step. Then we could take the second step, which was placing it as another high induction coil resonant on the output. Then we can go to the third step and make them interact in space, see the effects of the mutual inductance. And then we can go to the fourth step, which was to enable the construction of the third phase, which was at the actual phase that was determined to be the juxtaposed flux capacitor line connections. And now what we've done is gone farther than that. We've taken that phase completely out of the picture, and number 5 step that shows that we've taken that phase out of the picture and we've shorted its loop, and we got an amperage meter on that shorted loop, and so it's no longer part of the circuit. And then we made even a last step, which was to connect it in a one line only way to the remaining third element of the resonance. So there we try to explain in the chain of command what has occurred and what we want to do next. What we want to do next is look at all these field states from 1 on downwards. Over here is a diagram of when we had just the 3 connections without bringing in this fourth resonance into the picture, what the conditions of the circuit were, by referencing the internal voltage rises to the voltages between the phases, and that magnitude will fit geometrically wise into that thing to make a triangle. So then we have an idea of how the new arrangement from the 9 coil system has distributed the voltages in time to its next load. We'll call it quits real quick here. On the 9 meter measurements, then we can apply the law of cosines, and the first 2, since we have a voltage of 1 in the background before we even turn on the field, we can calculate the Q factors as the actual VI meter readings. Those are 2 of the situations on a no field. Here's a third situation with a 5 volt field. And what happens in the 9 volt, in the no field situation, doesn't always model what's going to happen in the real power situation. We'll stop there.